Thank you. Okay. Am I audible? Yep, I think so. Okay. Hello, everyone. So I'm Jolly Trivedi, and I'm studying my master's in cybersecurity at University of Turku, Finland. And today I'm here to present my idea, which I'm taking ahead as part of my thesis work to use LoRa in smart healthcare, but also how to address it at the security concerns. So I hope it will not be too technical, but I'll just try to balance both of the stuff, so maybe it could interest you to help me out with more suggestions on this topic. Okay, so quickly running with the agenda. Initially, I'll just do a refresher slide for healthcare in IoT architecture. Then I'll just quickly go through the challenges. And then specifically for which I'm here today is LoRa when in smart healthcare. So I will be combining LoRa, Azure IoT, and also smart healthcare, but specifically concentrating on remote patient monitoring. And then security areas, what are the security challenges which we are facing by implementing LoRaWAN in smart healthcare? How can we address it based on my research? And obviously welcome your feedback and inputs. And then lastly, just to address the buzzword of sustainability. So I'll also address a couple of sustainable development goals by using LoRaWAN in smart healthcare. Okay, so before I go into the technical stuff, this was very interesting quote which I came through, which was from the CEO and founder of Megasoft, that why we need smart healthcare, right? So we need it because we want to reduce the burden of elderly people. We have a lot of elderly patients who don't have anyone to take care about them. So how we can use it for taking care of them, plus obviously to reduce the financial cost, because in COVID we have experienced that there are a lot of hospitals where they didn't have enough space for people to be admitted, so everything was to be done as remotely. So this was one of the advantages of using smart healthcare. So a refresher course, we all know what is the architecture of healthcare IoT, but I wanted to specifically mention about the medical devices. So if you see over here, this one, these are e-health sensors. Now these e-health sensors can be of two types. One is invasive and one is non-invasive. Now when I say invasive, it's like there are a lot of healthcare devices which can be wear on the body part of the patients, and some are there which are just monitor the proximity. So I'll be concentrating on both of them because my concentration of this research part is remote patient monitoring, so it will cover both of the types. And then if you go, here we have the second layer. So here we have phone nodes and smart gateways. So here, in the next slides, I'll explain how we can replace the LoRa. But these smart gateways are used for processing the data, manipulating the data, for building up the logic, which we are collecting it from the sensors. And then comes the last, which is cloud. Now, this cloud can be any of the cloud which you want to use, but just now we will be concentrating on LoRa cloud and how we can use healthcare providers to create this application and monitor them. Okay, so before going to architecture, because the architecture which I have designed or which I'm exploring is basically mainly to challenge this, to address these challenges, which is patient data security and privacy. So now we are in Europe, right? So we know GDPR. So GDPR, what does it say? So we need to secure the data of patients. So it's really important that whatever data we are collecting of a patient, they need to give us a consent. And if they have given us the consent, they need to know where their data is used. And if that data is used, is it secure enough? Is it not misused? Because I remember there was an incident in Finland, an hospital called Vastamo. I hope somebody would be knowing here. And there was a data breach, and all of the psychiatric notes were all in the dark web. And because of that, patients went into depression more. A couple of them committed suicide because their all secret notes were into the dark web. So yeah, this is why we really need to make sure that patient data is secure and private enough. Integration. I'll collab this with another feature, which is device interoperability. Why? Because in healthcare, as I mentioned in one of the layers, we have a lot of sensors. Now, these sensors are collecting the data from multiple locations. from multiple parameters. So we need to integrate the sensors in order to make sure that the data collected is interoperable with our healthcare application where the monitoring is done. We need to make sure that real-time data is available. With bit of latency is okay, but we need to make sure that data is correct and on time. And then obviously, which everyone is interested, like whether it's technical or salespeople, cost and performance. So now why LoRa in healthcare? Why I'm thinking about LoRa in healthcare? So these are some of the main objectives which we always keep on discussing with LoRa. But with respect to remote patient monitoring, these are main features which I'm trying to address as minimum human intervention, because we don't want that the treatment of any elderly patient or any of the patient is dependent on the offline availability or the actual availability of doctors or caregivers or nurses. There can be the situation where they are not available, but then we want them to be remotely treated. So this is one of the features which we need to address, which is reduce doctors' engagement. And obviously, because the patient don't need to travel to hospital, patient don't need to get admitted to the hospital, resources are saved, and hence they reduce the expenses of the patient. And then we have, on the technical side, if I go, it's easy deployment of all the sensors, the healthcare application. I'll also explain the next architecture. And most importantly, low power, which is the feature of LoRa, where we have low power. Long-range communication is also possible with LoRa because we want that we can cover maximum number of patients in the maximum range. Obviously, it depends on the topology, whether this patient is in which distance, how many buildings are there, how much kind of concrete jungle is there, but still, it's much achievable than compared to other long-range protocols. So I am saying this based on the earlier researches done by earlier professors. I got some of the statistics where we know that LoRa is able to cover the range up to 30 kilometers. Obviously, again, as I said, it depends on the topology. And some more statistics, which is regarding the security, which is my main concern over here is, like in LoRa, it is say that it has been covering AES 128 encryption technique. But as per my latest exploring about LoRa Alliance, I have been told that now it is also supporting AES 256 encryption as well as block cipher. So this also makes it very strong to use LoRa sensors and to have the LoRa device collection data on Azure side. So I'm coming to Azure. Now why Azure? Because I want to have an application which is monitoring the data, which is collecting the data, and also which is analyzing the data, and it is also giving back the response based on this data to patients. Okay, so this is the architecture provided by Azure. If you see over here, we have this first layer, which is things, which is consists of medical devices. Then we have the second layer. Now there it says is Azure IoT Central or Azure IoT Hub. So this is option 1 and option 2. But I'll be going with Azure IoT Central. Why? Because I'll be getting a dashboard. I can collaborate my data collected from LoRa sensors, integrated with Things Tech, and then with Azure IoT Central. And then this Azure IoT Central Hub is integrated with FHIR, this FHIR, which is an Azure API, which is specifically a standard for patient health information. I'll also explain why we are using this one and how it is beneficial. But yeah, this is main advantage. And then, when we are collecting this data, we are able to also create the analytic report, which will again help us for the future analysis of the patient data. And lastly, it will be integrating with my healthcare provider applications where they'll be monitoring this data, like healthcare givers, nurses, and based on this data available, they will provide the services back to the patients located in this node. So now integrating with this with LoRaWAN. So as I said, on the first layer, we'll be integrating this LoRaWAN, which is specifically a standard for patient health information. I'll also explain why we are using this one and how it is beneficial. But yeah, this is main advantage. And then, when we are collecting this data, we are able to also create the analytic report, which will again help us for the future analysis of the patient data. And lastly, it will be integrating with my healthcare provider applications where they'll be monitoring this data, like healthcare givers, nurses, and based on this data available, they will provide the services back to the patients located in this node. So now integrating with this with LoRaWAN. So as I said, on the first layer, we'll be integrating this LoRa devices. Now, this can be, as I mentioned, invasive, non-invasive, water like temperature, pressure. If I want to have indoor quality of that hospital or the patient's room, like we have CO2, anything we can include over here. But again, I have a different scope, which I'll explain, but it will be integrated with ThingsTech, and then it will be communicating with the Azure IoT central application. If you see over here, I have a device twin over here. Why we have a device twin over here? Because we want to make sure that whatever is the state of the devices, when I say devices, they are the IoT sensors or LoRa-enabled IoT sensors, which are at the patient side. We are making sure whatever is the state of those devices is updated with this device twin, because we want to constantly analyze, we want to constantly generate the telemetry, we want to constantly generate the report and make sure that our patient is in required set conditions. And if in case it is outside the parameters or below the parameters, we can quickly generate the notification and send the alert, or if we can send the caregivers to their place. So this is the same thing which I have tried to explain. Obviously, it's with the source is Azure, Microsoft Azure Central. But if you see over here, we are combining, we can just combine this IoT hub to get the device telemetry from device twin, provide it with the Azure IoT Central application. Also, we get the provision to create a device. Now, creating a device is again creating a device twin. Like for example, I have a temperature sensor which is mounted on the patient side, and I want to create a device twin. I can have multiple device twin, but with a different set of parameters. So this is what it is provided if you see over here in this section. And most important thing is, because we are using Microsoft Azure, only the authenticated and authorized device can be logged into this network, because it is having role-based access policy, where only the user which are given specific privileges to specific group of users can only join the network and only join the report generation section. So this is the one which I'm working right now as part of my research is LoRa devices, then Things Network, and then I'm working on Azure IoT Central, but with an inner layer of Azure security, because I want to make sure that whatever data I'm collecting through LoRa-enabled sensors from the patient is secure enough. It is also encrypted. If in case any system is getting hacked where this device data is transmitted, it cannot be breached. So there are a lot of encryption techniques, one of them which LoRa is already implementing, but Azure also has this end-to-end encryption secure channel, so which I'm trying to implement over here. And then it goes with the FIR, which again I'll explain, and then it goes to my healthcare provider dashboard. Yeah, so this is how it will look, but I'll not go much in detail because I think I'm running short of time, sorry for that. But yeah, I'll quickly go with the FIR, which is a standard for making sure that all our patient healthcare data is compliant with this. And then it is also compatible with Azure. And why we want this? Because it's the most secure standard available, at least in Europe. Because for US, we have HIPAA standards and HITRUST, but for Europe, we just have GDPR and FHIR for secure data storage of patient healthcare information. And we are using FIR also because it gives a higher performance, low latency. Now, when I say low latency, because there should not be much difference between the incident occurred and the incident, the data which is available on my application. So there should be a real-time data available. Obviously, it's still not possible. There is always a latency or late detection of data of around 3 to 4 minutes, 3 to 4 seconds, but still, it's quite better with FIR. And as I mentioned, it's role-based access control data, which is very important for the security side. And then we have multi-region failover, because it supports multiple regions, but they also have a backup failover. So for example, if it's failing in one region, we have multiple instances of FIR. So you can instantly have the backup, and your data will not be breached. So this is one of the link which you can go ahead. You can just get the code over here, and you can also integrate with your application. You can also try the prototype for this one. Yeah. So these are the key values which I discussed already as part, but the most important key values which I would like to highlight for using LoRa with Azure IoT in smart healthcare is secure data transfer, which is my main concern over here because there are a lot of healthcare applications, but where is the security? So this is the most important thing, and user access control. Obviously, then it comes with the subsidiaries like alerts and notification, but these two things which I'm trying to address by this architecture. So scope of my research right now is fall detection, medical refrigeration. So these two are already available with LoRa-enabled sensors, but now what I still am working on is how to address the issue of electrocardiography, how to address the electrical signals of heart, then how to address electromyography, electrical movements of muscles through this architecture. Then next is electrooculography, to understand the movement of your cornea. And last but not the least is electroencephalography, which is for understanding the nerves and brain's functioning. So the first two are really available, so I don't need to do much. But last four is main concerns which I'm trying to address with this architecture, which is still a challenge for me, but yeah, any of the feedback, input, suggestions are welcome. So quickly going to the security areas, I'll go with my applications, or rather the solution which LoRa is providing for the security issues in healthcare is, first of all, secure ID. As I mentioned, only authenticated users, only authenticated devices can get into the LoRa network, and this can be attained by secure ID of the devices. Then, in the LoRa application, whenever any device is communicating in the network server with the sensor, we have a unique network session key and application session key, which can again make sure that only those authenticated devices are allowed to be in that network. Again, it is integrated with Azure IoT. So we are also collaborating it with the RBAC, that is role-based access control. So we are combining both of this and making it sure that there's no authentication issue. And then we have device identity. As I mentioned, they have a unique device ID. And integrity, yeah. So this is, again, the people who are using LoRa sensors, we know that when we are registering into LoRa network, we have this MIC code generated for each of the devices. And because we have end-to-end encryption in Azure, because communication channel in Azure is also end-to-end encrypted, LoRa sensors also, it's also an encrypted channel, the LoRaWAN protocol which we are using, it is also protecting us from the spoofing. So eavesdropping, as I mentioned earlier, it was using only AES-128, but now it is also using AES-256 and block cipher, so it also protects from eavesdropping or man-in-the-middle attack. And lastly, interception and replay attacks, it just encrypts the communication channel. So yeah, I think I would like to end up my presentation because I'm over the board, but welcome for any questions, and I'm also expecting some feedback or any of the inputs from your side for my research work. Thank you.
Yes.
And I'm sorry for going overboard.
No, you're perfectly on time. So we have 2 more minutes before the next speaker. Thank you very much. Sorry. Two questions. The first question is, you're doing research, and your research would really benefit from feedback from the audience, right?
Yep.
So how can people reach you? Are you walking around? If they want to give you feedback to make the research even better, how can they do that?
Yeah, I can provide my LinkedIn ID for sure, or maybe I'm just at the backstage as well, but maybe you can find me in ThinkStage only. I'll be here itself till end of the session, so you can connect me.
So if you want to contribute to smart healthcare, it would be very nice to give some feedback. And then secondly, I was wondering, we had a lockdown, we had COVID. Do you see a big difference before COVID and after if it comes to smart healthcare?
Yeah, definitely. I think smart healthcare has boomed like anything after COVID. Because earlier only the people thought that it's a luxury, but now they think it's a need, because it's really not possible every hospital to get admission to every patient, right? So it really like every hospital is trying to be smart hospital, so that if they don't have enough resources, they can at least provide them remote healthcare advices or monitoring, or like any kind of remote services which they can provide to the patients. So at least in that way, it has become a bit of advancement in healthcare services. So it's like COVID has been a boon to healthcare rather than other things. So
Awesome. Great. Thank you very much.
thank you.